If I can see it.
Okay. Sorry, you have not gotten to this place. Uh, so we are talking about manipulating and processing data in R, and I think we've got to a point where we're talking about subsetting, like creating subsets. So let me see. Yes, we are just here. So it is another way of subsetting data that has a name. In this case, I'm trying to perform an arithmetic operation on two separate columns called separ.length and separ.width in the iris data set. So I'm saying divide separ.length with separ.width and assign this operation to x. You're going to have a vector of numbers. So these are the points I have after this operation too. So and also I can also perform the same operation that I did here using the width function. So what does this width function do? So what does it do? So I'm saying with the iris data set, do this. So instead of me having to call separ.length referencing the data 2 times here, so me for me to be able to call this column, I have to reference the data I'm calling it from. Then I said divided by iris after separ.width again. But with this width function, I just have to call the data once. I say with this data, do this column divided by this column. So it's just going to perform the same thing that this actually did here. So you can see that the result is the same thing as what we got here.
This head, is that a function?
Yes, the head means give me the first 6 entries I have. At the first 6.
Oh, okay.
Let's say I have a data. You want to see the first 6 records in that data. The head function can help you with that.
And then, is it horizontal? It doesn't display it in rows.
No, this is this is a single vector. That's why you're having this. So let me show you something. Can you see this? Can you see my screen? This is my
yes.
Okay, so let me call head of iris now. Head of iris. That's the iris data set. As you can see in my screen here, it gave me the first 6 records like this. But if it's just a single vector, so that's how you see your results. You are seeing it here.
Oh, okay. Okay.
So if it's a data frame, it's going to give you the first 6 records in this format. But then if you need more than just 6 or fewer than 6, you can specify the number of records. If I just need the first 3, I can just put comma 3 here, and run the command, it's just going to give me the first 3. As you can see. If it's the first 50 you need, you can just put comma 50. Then there is also tail. Tail is to see the last 6 by default. But if you want to see the last 3, I can just put tail of iris comma 3. It's going to give me the last 3 records. As you can see here, I have the last 3 records of the iris data set. Okay.
Yeah.
Now, sorry, let me check. I think someone is in the lobby. Please hold on. I think someone is trying to join, but I can't see the person, so that's why. So also we have the within function. Now the within function is, I'm saying within that data set, help me to perform this operation. Now the difference between this and this is that now this operation that I just did, this operation, I called it ratio. So ratio is going to be another column in the iris data set within the iris data set. So it will just assign ratio to this operation that I just did. So I have the separate length column and the separate length column, and I want to have a separate column which is going
It
to
will create a new column titled ratio.
yes, having this operation that is doing the separate length column divided by the separate width column. Exactly. Let me see the question is here. I don't know the class that she went to join. I should have seen her in the class, but maybe she went to go and join another class. So that's what this within does. So now moving forward, so let me just show us. So iris, I want to do the within iris, within iris ratio equals to separate length divided by
Can you nest this line of code within the head function? This within.
okay, this
Can
can I do what?
you nest this line of code that you are writing within the head iris something? I just want to.
Something like this.
So, okay, yeah,
You can see it now.
yes, I can see it.
Okay, so if I should run it now, you can see a new column was created within the iris data set called the ratio. Let me show you in the console very well. So this is the ratio column now, having this divided by this within it. Okay.
Okay.
Um, let me check whether sheet there. I can't find the. So, uh, yeah, we're talking about creating subgroups or bins of data. So, let's say, for example, you want to plot an histogram, then you want to group your data into separate bins, and then you can use the cut function to do that. So, how can we do that? To, to consider this example, I'm saying cut this particular column into three levels. Then I use the include lowest to include the lowest number in the in the in the column or the vector or whatever it is. So let's say for example, okay, let me accept the person, but even the person I'm expecting is here. Okay, so let me show you something. So let me check the range of this column. Iris, ampersand, separate length. And the range of this column is 4.3 to 7.9. What does it mean? It means that the lowest number in this column is this, while the highest number is this. Now, I want to break this number into bins. So I want to break it into bins. I can do cut into brackets, then I'll specify iris, pattern, separate length. Then I can say, okay, I want to cut it into intervals, like three groups. So if I should want this, by default, it creates the groups for me by default, but I can specify the grouping by myself. What it does by default is that it groups numbers between 4.3 to 5.5. Then you have another one from 5.5 to 6.7. Then the third one you're going to have is 6.7 to to 7.9. So it starts from the minimum to the maximum. So, so basically, if a number falls into category, it gives it this particular interval. But you can give it a name. You can give it a name if you like. If you don't want it to be this, so let's say you want to group some the salary column into three equal parts. And you can say, okay, you can give the lowest part, that is this part, let's say lowest, and the second part medium, and the third part high, mean low salary, medium salary, and high salary. Just that basic illustration. So to see the number of uh, the numbers that fall in this category, you can use the table column to aggregate this result. If I say table into bracket this, so this means that 59 entries fall into this category, while 71 entries fall into this category, and while 20 fall into this category. You can use this to plot histogram, say histogram of, you can just do a bar chart with this upload of people. Then you have something like this. I can flip it, but using a base app package plot is not really interesting. But by the time we get to GG plot, you find visualization very, very interesting compared to the base app package using for plotting. Okay. You can see here they gave it a label. As I said earlier, you can give it a label if you like. If you don't want the interval format of the label, so you can say, since I'm grouping it into three parts, so the first part is I'm giving it low, the second part I'm giving it mid, which means medium, and the third part high. So you can categorize it in this format, and that's just it. So now here we are talking about how to merge or combine data sets in R. Now we have background noise. Okay, so we have the C bind and the R bind, which is the basic kind of joining when you want to join side by side or top down. The C bind is to like join side by side. That is column. C bind is column bind. To join column wise together, like place just side by side together. Then the R bind is to place top down from bottom up. Then we have the merge, which looks like which is like the join that the join we do in what's it called, SQL, inner join, left join, right join, full join, and the like, cross join, which that's also important. So we have the merge, which can use to do all those stuff. So let's see how this works out. Let's see the next slide. Okay, so first of all, I'll talk about the C bind and the R bind before I now come back to the merge function. Now, as I said earlier, C bind is to join side by side, that is column wise. So let's say I want to C bind or column bind two vectors now. So I want column bind 1 to 10 and say 11 to 20. So if I run this now, see how it is. So 1 to 10 as a single column, 11 to 20 as another column, side by side in that format. Now, 1 to 10 is of length 10. 11 to 20 is of length 10. And what if you want to combine two vectors that are not of the same length? Then what is going to happen? It's going to join it, but it's going to come with a warning. Um, Let me say 11 to 19 here now. If you want this, you can see warning message in this. Number of rows of result is not a multiple of vector length of argument 2, meaning that both of them are not of the same length. But what happened when they join it? You can see that when it got to 19 here, he placed the last entry here as 11. That is, it just started from the beginning and just replaced. The same way, if you stop at 18, it's going to replace the next two with 11 and 12 accordingly. Just going to start from the beginning to append it. So that's what it's just going to do for you. But if you are joining with some kind of another function, it will just pop up with an error and it won't do this for you. It won't do this for you. But you just have to understand how you use them. This is cbind. Then I can do argbind. This is going to do from top down. I can say argbind, say 1 to 5 and 6 to 10. You can see for top down, like on a row wise, that's how it join the two of them together. The same way, if they are not of the same length, it's start from beginning to complete the binding. I think that is well understood. Now, coming to the merge function, we have the natural join, like the inner join. We have the full joins, you can say full outer join. We have the left join and the right join. Now, the inner join or the natural join is when you are trying to join a table A with table B, whereas you are joining based on the columns that is common to both of them. Then it's just find the intersection between those two tables. So it joins when, okay, let's say for example, I have table A, which is the employees table. Then you have another table B, which is the department table. Now, in the employees table, so let me accept something to recall. Faida, you're welcome. So the employees table has a column called department ID, whereby the department table also has a column called department ID. Now, if I want to join, so if I want to see employees, the department of the employees in the employees table, since I have to join the employees table with the department table using the department ID to connect the dots, connect them together so that I can see the information of the department that a particular employee belongs to. Let me see if I have illustrations of, I have the data sets that I can use to illustrate that. To, I think, download the, where do I have it? Desktop, documents, think downloads data sets. So let me check this please. I have employees. I do have departments. Let me see. So should I just, sorry that was good. I want to get some data that I have here. I think I can use properties. Including some data. Uh, how can I find this? Okay. So, so let me just use this. Employees, departments, CSV. Okay. So, uh, going back. So let me just load the data set into my R environment. So I have it on downloads. So let me get working directory. Uh, then I will read the employees data set. But CSV files, CSV. Read the CSV, that's what I will use to read it. Then the department file, I'll call it DEPT, CSV, read.csv. Then I will just, yeah. Let me just copy this directory. Just copy the path. Sorry, this is not what I want to copy. I'll change this document to download later. So under into my files are under downloads. So what's the name of the file? Uh, you can see employees and departments. Okay, so employees dot CSV, then department department dot CSV. I'll change this from document to download, and also this download, and I'll read them. What's one? Cannot open connection. I think it's downloads, not downloads. Downloads. Okay, so it has read the two files. So if I want to see the content, I can say head of DFP. Just want to see the first three rows. So I have this employee ID, first name, last name, and this information. Also, if I want to see what's inside the department table, that's DEPT, I just want to see the first three records. So this is what's inside. Now, in the employee table, I have employee ID, which is a unique ID that identifies the employees. And you have the email, the phone number, the hire date, the job ID. You have salary, you have commission, you have manager ID, then the department ID. Now for department table, I have department ID, which is the unique ID that's associated to each department. You have the manager ID, that's the manager of this department, then the location ID. Now, if I want to answer a question that, okay, what department does each employee belongs to? Then I have to connect the employee ID with the the employee table with the department table. So how do I connect them? I have to connect them using the merge function, using the inner join. The inner join. Now remember, the inner join will only join based on when the two columns we are trying to use to merge the two tables are equal. Now, if an employee does not belong to a department, then it's not going to pick that employee, because at that point, the department ID of that the employee will not have a department ID, so it means it won't be able to connect. But then you can use. Then we talk about left join, right join, and full outer join. So if you want to see the whole information, you can do a full outer join, and then you can see the employee that does not belong to a department and a department that does not have an employee. You can see that the same type. Let's just take this one step at a time. Now, so I can say merge. I can say merge. So I want to merge. I want to do an inner join. Merge the employees table with the department table, and uh, then yeah, all is equal to true. And see, if you are using, that's if you are doing full outer join, but if I'm doing a natural join, I'll use all is equal to false. So in this case, I'll put F here. Then I will not specify the column I'm using to join. I won't specify. Now, why don't I want to specify? If you look at the employees table, the department ID is named department underscore ID. If you look at the department table, the department ID is also named department underscore ID. So with this, maybe I just have to specify because I have manager ID here in my employees table, and I also have manager ID to department table. So let me just use to specify that. Okay, I'm using all dot x equals to this and all dot y equals to this. So what I'm saying is that I'm using department ID in employees table, that's the X guy, and I'm also using department ID in the department table, that's the Y guy. Join these two together. So if I run this, sorry, I said all dot x, not all dot x, by dot x and by dot y. So what I'm saying is that I'm joining these two tables by these two columns. So this is for the column that belongs to x, and this column that is in y. So let me just run this again. We have this. We have this result. So here you can see the department ID, the employee ID, the name of the employee, the phone number, then you can see the hire date, job ID, and the department name, which is administration. It means this first employee belongs to administration department. Then the second and third employee belongs to the marketing department, like that, like that. So that's how to do the inner join. Now, let me just make this very intuitive, Or let me ask, do you understand what I just did?
Yeah, it's like the one we use doing SQL bar.
Yes.
Okay.
This is inner join or natural join. Now, if I want to do a left join or a left outer join, now in this case scenario, if I'm doing left outer join using the department ID in this case, the information I'm trying to get is that I want to see I want to select everything on the left. Now the guy on the left in this case is the employees table. Then match it with what correlates on the right. Select everything on the left and match it with what correlates on the right. That is, select everything in the employee table and match it with what correlates in the department table. That means I want to see every information about every employee, but sometimes, so it means I want to see the information of every employee related to the department table. But some records in the department table or some records in this left outer join might be null because not every employee belongs to a department. For example, I might have a general manager. Maybe I have a company. Then in each department there is a manager in each department. And you can have a general manager. That general manager might not be in the department, but it's also an employee, but does not belong to a particular department. It's just overseeing everything. So that person might not have a department ID, whereby it means the department name of that person will be known. So, but then you see every information of the employees. Then for that particular employee, the department name is going to be null and the department ID. So let me run this. Now, if you see this now, this is a left, no, this is still an inner join. So if I want to make it a left outer join, I'll say all dot x is equals to true. That means select everything on the left. All dot x is equals to true. So let me run this again. So this is a left outer join. So here I have all this information. So let me check the department ID, whether there is a pointer by the department ID is null. Let me check. Okay. This didn't give me a full picture of it, because if you look at down here, if I come down, you can see that it said maximum 36 maximum print and it has permitted what 36 records. So I want to see everything. So I'll use the view command, the view function. Say view is with capital V. You can see it's capital V. To view this so that I can view it. It's just pop up at this place here, this top here. So let me just scroll down. I'm looking for the department ID that is null. Let me just scroll whether there exists anyone. Okay. Okay, yes. You can see this person does not have a department. That's why the department ID is null. His name is Kimberly Grant, and let's see the department name. The department name should also be null. You can see it does not belong to a particular department. So that's just it. But all of these ones that have department ID, they belong to a particular department. Means that department name is not going to be null, and this is their department name: accounting, finance, and all of that. Okay. Now, we want to do a right outer join. The difference is just that what I'm going to specify here is all dot y is equal to true. So let me just view this. I'll just change this one to all dot y. This means select everything in the department table and join it with what? The employees table. Now it means I will see all the departments. Then I will now match it with employees in the employees table. But then some department might not have an employee, because maybe by venture the department was just created and they have not employed people in that department yet. It means the employee ID and employee name for that particular department is going to be null. There is not going to be a record for it. So let's view this. So we have this. These are right outer join. So let's see whether there is a place where the employee ID, the name, and all of that is null. In that case, you know that in that particular department there is no employee. So let me just scroll down. You can see all of these ones, they are NAs. There's no record of employee. So let's check the departments, all those departments. So they're saying that the treasury department does not have information about employee, the corporate tax, country and credit, shareholder service, contracting, and all. So all of this department does not have an employee in them. So that's just basically it. I hope you understand.
Yeah, right. So that means the view function view any database.
Sorry, your network is breaking. What did you say?
No, don't worry. I just discovered that I used to even do data sets, tabular form.
Okay. So full outer join and full outer join is just going to, what's going to change here is that instead of all dot x or all dot y, it's going to be all is equals to true. Then in this way, you see everything in the table in the left and the table in the right. Then it's going to join both of them with what matches. So it means it's possible I can see an employee that does not belong to a particular department, and I can see a department that does not belong to, but that does not have any employee in them. It's just like the combination of this left join and right join at the same time. So that's full a full join. That we get. So if I run this, this is a full join. So if I scroll down, you might see some instance where department ID is null and employee records are also null. So you can see this is the part whereby the employee record is null. That is, there's no employee in this department. Then you can see, you are going to see that last guy that does not have a department ID, that does not belong to a department. So you can see it here. It's in Kimberly Grant again. It does not have a department. Which, yeah. So that's the concept of merge as it joins in R. Okay, moving forward. So to the next one. Yeah, we talked about working with lookup tables. This one is just like I'm trying to see. Sorry, I'm trying to see where this particular column matches with this particular column. So in case a full merge is required, a lookup table can be used as follows. So for example, I want to see where the employee ID in the employees table matches with employees ID. Sorry, department ID in the employees table matches with department ID in the department table. I can use this guy. So let's just take a look at that. So I want to see match of PMP ampersand department ID over DPT ampersand department ID. So here you can see that this is where they match. This is where they match. So let me go to what's it called again? This view. So this is where they match 9, 6, 10 at the position. Then you can see there's one NA, one particular NA there, which means it is that guy that does not belong to a department. You know, there was a guy that does not belong to a department. So this is the NA that we're talking about there. So that's just basically now sorting and ordering data. We can use the sort function to order our data set, or we can use ordering is just to get the order of a particular vector. So I will explain the difference. So let's say I have this vector. So let me just create a simple vector. Look at VEC. Look at this VEC, for example. Now let's say I want to sort VEC. You can see I've already sorted the vector in ascending order by default. It excludes the NA by naturally, just exclude the NA. So that's the null value. Now, if I want to sort it in descending order, I just have to put DESC, descending or decreasing equals to true. I don't know why it's not popping up. Decreasing equals to true. So it's going to do that in descending order. Then if I use the order function, now first of all, one VEC, so I understand how the order function works. Now if I use order for VEC. Now this order, it just tells you that now this one, one is the lowest there. Now one is supposed to come first, right? So one is supposed to come first in ascending order, so that's why one is here. Now To the next one, I have 3. Now, is 3 supposed to come first? No, 3 is not supposed to come first. 3 is supposed to come maybe third. But let's go 1. After 1 is what? 2, right? 2 is supposed to come next in ascending order. But what is in position what? Position 3. That's why you have 3 here. Now, after 2, I'm going to consider the next number, which is what? 3. This is the next 3 that I have. But 3 here is in what? Position 2. So that's why you have 2 here. Now, the next number that is going to follow, I have another 3. But 3 here is in position 7. That's why you have 7 here. Now, after 3, do you have another 3 again? No. So after 3, I have 4. Now, 4 here is supposed to be the next number, and it's in what position? 4. That's why you have 4 here. And that's what this order does. It just give you the order of how the person is supposed to look like. So then I can just put, say, EC into square bracket order EC. This just does the sorting for me, as you can see here. We just sorted everything in proper order using the arrangement of this order function. So that is basically it. Now, I'll still going to talk about some important subsetting. You can use logical Boolean value to subset, logical operators to subset, which they are very, very important. Okay. Now, I'll talk about how to use the order. Now, now traversing data with the apply function. We can use the apply function to traverse our data in the way it suits us. Then we have the apply function, we have the L apply, we have the S apply, which are the 3 kind of apply function you can use for your data. So the apply function traverses either the rows or columns of the matrix, applies a function to each resulting vector, and returns a vector of summarized result. Say for example, I have the iris data set, for example. So head of iris like this. Okay, let me accept someone to call. Just okay. So as I have this head of iris. Now, this species has 3 categories: Setosa, Virginica, and one other category like that. So let's say I want to find the average of sepal length per each category in species. I think I can just use apply apply on iris percent species. Mean sorry. Mean of iris percent sepal length. Oh, sorry. Apply on this guy. Mean name just call. Let me just call it the data manually like this. Yes, yes. That's my margin. Margin is equal to column. Yeah. Sorry. I argument margin is missing. Just hit that. I'm missing something. I'll come back to it anyways. Also, the list apply it can be used on a list. I think I should proceed to see how that one too is applied. Then we have the S apply. But let's first of all talk about the apply function. So X, this is the data, an array or matrix. And the margin is the numeric vector that indicates the dimension over which to traverse. One means rows, two means columns. So I want to aggregate over rows or over column. So if it's over rows, I'll use one. If it's over columns, I use two. And fun is the function I want to apply to that data, whether it's the mean, the sum, the maximum, any which one I want to apply on it. Then okay. So we also have T apply and S apply. And T apply function can be used to create tabular summaries. Similar to S apply. So the function can take three arguments: X, which is the vector you're trying to consider, then index refers to the factor or list of factors, then function refers to a function you want to apply on it. So for example, I can use T apply on what I was trying to do this time. Let me just then I can just do ampersand separate and see so here you can see T apply just did found the mean of sepal length for the setosa category, the mean of sepal length for the versicolor, and the mean of sepal length for the virginical category. So this is the vector, this is the index, and the function you're trying to apply. So also then you have introduction to formula interface. If you want to use the formula with the apply function, you can talk about this. Then this one is talking about let me see. Okay, converting data into long or wide format by using the melt or recast function. I think, yeah, using the library shape too. You can use melt and recast function too. So here you want to correct what is this? You have a data set space in wide format and you want to convert it to long format. You can use the melt function. Or if you want to convert from long to wide format, you can use the recast function. But then, so let me go back to the apply function again. Sorry, excuse me. So so I want to do what is it called? Apply. Let's see. I want to apply on iris, the iris data set, considering the first four columns. That's the continuous variables. So I want to aggregate over what's it called? Over the columns, because I'm using 2 as the margin. Then what function do I want to apply on it? I want to find the mean. So what this means that I want to find the mean of sepal length, the mean of sepal width, the mean of petal length, and the mean of petal width accordingly. So this is the average of sepal length, the average of sepal width, the average of petal length, and the average of petal width. So I just wrote iris 1 to 4 because I already know the index, the position, because I'm doing this. So I'm excluding the last column, which is the species column, because it's a categorical variable, so I can't perform mean on it. So that's why I didn't include that. So then you have the S apply, which gives you your results in a matrix format compared to L apply, which gives you in a list format. So let's say I want to do iris. I want to do this iris. How should I relate it over now? I can do the same thing as what I just did here. Let's copy this. But I don't need the I don't need to put function. Just so I don't need to put margin rather. So it just does this for me and give me in matrix format. So this one just aggregates, find the mean of each column and just give me the result in this format. While if I do L apply, it's going to give me in a list format. If I do L apply, it's going to give me in a list format instead of matrix format. You can see the way it gave me my result in a list format. So that's just so they are exciting functions that can help you with data cleansing and all of that. But then before I go into that, let me talk deeply about the data structures, the four data structures considered in R, which is vectors, matrices, lists, and data frame. I've not talked extensively on those data structures, but I know I've talked about vectors. Now, for matrices, this is the way you create matrix. Use the matrix function. Now, then you pass in a vector, let's say 1 to 25, then specify the number of rows you want to have and the number of columns. But if I say the number of rows, I will use n row is equal to 5. Now, you know that the size of the matrix is the number of its column and the number of its rows. So if number of rows is 5, and the length of this my vector is 25, it means by default my number of columns should be 5. So I don't need to specify, but you can explicitly specify later. Now this next thing I need to specify is by row. Do I want it to create my matrix by row or by column? If I want to make it to do it by row, I'll put by row is equal to true. If I want to make it to do it by column, I put by row is equal to false. So since I want to create my matrix by row, I'll use by row is equal to true. So let me run this. Now you can see this. We created 1 to 25 by row, having what 5 rows, because I've specified that I need 5 rows. So you have 5 rows, 1, 2, 3, 4, 5. And the columns I'm going to have is also 5 because the size of my matrix is 25. So you can see it created the matrix by row. You can see it started from 1, 2, 3, 4, 5 for the first row, then 6, 7, 8, 9, 10 for the second row until it has created the matrix for me. You can give it a name. You can give the dimension. You can give it a name if you like. But by default, it just creates this kind of default indexing for me. So this is row 1, column 1, row 1, column 2, like that. So that's just it. Now, if I want to give it a name, I can just use this inside this parameter. I put dim names. All right, dim names is equal to list into bracket. Then the first thing that is going to go into the list is the row names. Now, I want the row names to be first 5 letters in the English alphabet. I'll use the letters vector, input letters vector is in R to give me the first 5. Then my column name should be the last 5 letters in the English alphabet in uppercase. You have letters in uppercase, letters in lowercase. So this letters in uppercase is at the English alphabet in uppercase from A to Z. So I want the last 5 letters. That would be 22 to 26. I think we have this. So by the time I run this now, you can see I have my matrix created with A, B, C, D, E as my row name and B to Z as my column name. So now, let me assign it to a variable called MAT that I can use it again. Now, if I want to subset matrix, the same way you subset data frame, you can also subset a matrix that way. So let's say I want to call all the rows corresponding to 1 to 3, 1 to the third column. I can do this. So if I want this, you can see it gave me all the rows corresponding to what the first 3 columns. So the way you subset data frames, you can also subset matrix like that. Now let's try and do this. You can see when I do the ampersand sign, it does not give me an option. It means I can't call a matrix using the name, maybe row name or column name. I can't do that with the matrix. Now I also talk about, I think that's all I'm going to talk about matrix. Do you have any questions as regards matrix before we move on? Hello. Okay. Now, running vector. This is a vector that I've created before. I can give it a name. Then I will say I can explicitly just type names in bracket. Then the name. Sorry, I will say names of VEC now equals to. I want to give it how many of them do I have here? I think I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. So I'll give it the first 12 letters in the English alphabet. That's 1, 2, 12. Okay, I've named my vector, so I call VEC. You can see each of them has a name now attached to it. Now let me try to say I want to call them by name. You can see I cannot use the ampersand sign with the vector too, but I can call it by their name. If I want to call it by their name, I can say vector square bracket. Then I put let me say H. I want to call the guy H. That is, I want to call this guy. So let me run it. You can see that it gave me my result for the. I can also call them by position. It doesn't matter. Also, my matrix, I can call my matrix by name. So let's say I want to call all the records corresponding to the Z column, capital Z. This is what I have. And see, let's say I want to call it corresponding to X and Z column. I can just put it in quotes in the combine function like this and say X and Z. You can see I have all the records corresponding to X and Z. So let's say I don't want all the rows, I just want ABC rows. I can just, so let me just put 1 to 3. You can put 1 to 3 like this, or I just put ABC in like this too. Anyway you like it, and do this. And see, it gave me values in the columns exit corresponding to what rows A, B, C in that order. Now, to create a list, I'm talking about the list. A list can contain anything. You can have a list inside a list. You can have a data frame inside a list. You can have a vector inside a list. You can have a matrix inside a list. You can have anything. So I want to create a list. Let me call this my list. So I'll use the list function to create it. Inside this list, I'm going to have a vector inside it. So I'll call it my vec equals to DAC, which is the list I've created before. My matrix is equals to M80 I've created before. My data frame is equals to I'll put iris inside. Now I want to put a list inside again. Let me call it M list. It's equals to list 1 to 5. Now I've created it. So let me call my list now. This is what is inside. So the first entry you can see there is what? My vector. This is the vector I created. And the second one you can see my matrix. There. The next one, DF as data frame. Then the last one is the list I created. You can see that this is a list. Now, if you want to subset in list, you can call them by name using the pattern sign. Since if it has a name, you can see this is what are inside the list: my vector, my matrix, data frame, and M list. So I can say if I want to call this guy that is inside my list, I'll call it with the pattern sign, and this is the guy. I can call this same guy with position. I can say my underscore list double square bracket 1. Now, if I use a single square bracket, let's see. It gave me with the name, but I just what is inside. That's why I use double square bracket. So if I just do this, it's giving this guy, but also with the name. If I don't put this name, it names this guy with its position. So it's going to put double square bracket 1 as the name of this first guy. So that's what it's going to put by default. Now, I use this double square brackets to call this. So what if I don't need everything? I just need maybe the last or the guy in the 7th, 8th, or 7th, 10th position. Then I can just put after this double square bracket 1. I'll put a square place. Then I put 7 to 10. It means inside the first element in this list, which is a vector, give me the first or the element in the 7th to the 10th position. So if I want this, you can see these are the guys in the 7th to 10th position in the first entry in my list. So I think that's that about data structure. Now, I want to talk deeply about indexing. Now we've looked at some instances on how to index using position, using name. What if I want to index based on particular operation, maybe a logical operation of Boolean value. I can do something like this. Now, look at this now. We've talked about some functions in R, like the duplicated function. I don't think I've talked about unique function. Unique function is used to get unique values in a particular vector. So if I want to get unique values in VEC, I can say unique into bracket VEC. That unique values that are inside. Now, say let me call VEC again. And this is VEC. And if I want to get values that are greater than 5 in this VEC, how do I subset it? So it means I have to use a particular condition inside this square bracket. Inside the square bracket, I will now say VEC greater than 5. That is, I'm saying call VEC based on values in VEC that are greater than 5. So if I should run it, you can see I have this result. NA will be called by default. NA is going to be called by default. That doesn't mean it's greater than 5. So you can see the values that return 6, 8, and 12. These are the values that are greater than 5. So you can omit NA if you like. So also, I can get position. What if I want to get the position of those values that are greater than 5? I can use the which command, which is very essential. You have to know it. Very essential, very useful. So if I say which is greater than 5, don't give me the position. So it's saying that they are in position 9, 11, and 12 respectively. So if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, then 11 and 12. So these are the position of the guys that are greater than 5. Now, this VEC greater than 5, what does it even do? It returns a Boolean result, that is false and true. False if it does not satisfy that condition, and true if it satisfies the condition. So is this true and false value that is inserted inside this square bracket to give me the result I want, I can see here. So these things are very, very, very important. But if you want to subset based on equality, now when you comparison, you use double equality sign. So let's say I want to get VEC for VEC value that are equal to 5, you use equal. That is, you are comparing your left hand side to your right hand side. You can do this. So if I should run this, just give me 5, 5. Then it's going to put this number values before, since it's not number. So that's how you subset using logical operators also. Now, not equals to is this. You use the exclamation mark with the equality sign. So exclamation mark equals 5. This is how you do it. Means give me values that are not equal to 5. So you have this result. These are the guys that are not equal to 5. So these things are very essential. You can use the data frames and things and all of that. So it's very essential. And yes. So this guy in this square bracket are Boolean result, as I've said. False if it does not satisfy the condition, and true if it does satisfy the condition. Let's take a look. Do we have any question before I go into deeper into data manipulation and I want to go into an interesting part. So I think I'm not going to another session next week, but I'll just talk about the package that we can use for data manipulation. Hello, are we together? Hello? Hello, can you hear me?
Yes, you
Okay.
can.
Okay. So, and there's a package in R that we can use to do data manipulation. It's called dplyr. It's called dplyr. But it comes together with a package called tidyverse. If you load tidyverse, the player package is going to come with it automatically. So tidyverse, as the name sounds, to tidy your data cleansing, data manipulation, whatever you can think about. A lot of the data visualization and so you can use tidyverse. So if I want to do use the player, I can say library. First of all, if you might not have it by default in your app, so you just have to install it. To install the packages command. So tidyverse, I want to load tidyverse into my house. So you can see it has loaded tidyverse. So in tidyverse, you have the entire package you can use to tidy your data. So let's say, for example, I have this. I'll be using iris dataset. So I want to now. So let me show you the iris dataset for you. This is the iris dataset. Now, suppose I have a dataset that has so many variables, like over 50 variables at a time. And sometimes to be calling them by columns or calling them by names, by positions can be frustrating sometimes, can be frustrating. So, and you just have to, they have some kind of pattern related to them. There's a way you can even select it. So you have the select statement in the file, select, all these verbs are very important, select, select, transmute, mutate, arrange, and all of that. Now, let's say I want to select only columns that has length in this iris data set now. Now, I can use the select statement and say, okay, select from, let's select function in the file. Select iris. From iris, I want to select columns that contains, I'll use the contains function, contains length. If I should want this is going to select iris dataset that contains length. If I should want this now, you can see here that it returned what? Separ.length and what? Beta.length. There are some verbs, functions that are also essential, like I can say end with. I can say give me columns that end with a particular string, or even start with particular string. I use it also. If I want to say start with petal, I can include start with petal and also I don't want to say not end with. I'm not using end with, or let me say start with, end with and start with petal. I should want this. Result. It gave me everything that I needed. Now, furthermore, I can use some operation with this. I can do some operations with this guy and say, okay, maybe I want to find the mean of these guys. I can go further and say, okay, from this guy, I want to find the mean. I can say, I can use this symbol. This symbol means following from this command. Following from this command. That's what this symbol means. So following from this command, what do I want to do? I want to find the mean of, say, separ. I can just explain this with separ.length. If you want this command now, sorry, so I can't use this. I forgot I'm using the player factor. So I can say summarize. This I want to like summarize it. Say mean of this. Summarize using the mean of this. So if I should want this now, I can say I have the mean of separ.length. I have the mean of separ.length. Then if I want to find another mean of, I can say mean of say beta length. Just give me the two of them together. As you can see here, then I can keep on like specifying like that, like that. Then, okay, let's say I want to now pick everything. If you want to pick everything, let me just okay, let me write on another line. Say select, I say select the iris dataset. So from the iris dataset, I want to pick everything here. I'll use the everything function just like this. And I'll say following from this, I want you to help me to group by spreadsheet. I want to group by the spreadsheet column. After grouping by the spreadsheet column, so following from this also, summarize what I have by mean of, let me just copy this inside, mean of sepal length and mean of petal length. So what this is going to give me that it's going to give me the mean of sepal length and mean of petal length for each categories in the spreadsheet column. So if I run this now, you can see so this is the category for setosa. This is the mean of sepal length. For vesica, this is the mean of sepal length. For virginica, this is the mean of sepal length. For setosa, this is the mean of petal length, and for vesicular, this is the mean of petal length at right seven. So this makes it very easy for you to aggregate your data, like, and do a lot of things. You can also transform your data by adding some uh, adding a particular column or anything. Like say for example, I want to say okay, from every following from everything, do after selecting iris, then transform. Transform the base packaging path and mutate and mutate add ratio to it, which is going to be equals to sepal dot length divided by sepal dot width. If I should run this now, this is what I have. You can see that it has added another column called ratio to have this. So a lot that you can do using the dplyr package for aggregating the data and all of data aggregation and data transformation. Very, very interesting. Very, very interesting. So uh, moving forward, moving forward, you can read about the dplyr package and a lot that you can do with this. So it's embedded in the tidyverse package. So we're talking about getting started with shape 2 package as used for putting data into shape. That's maybe putting your data in long or wide formats. You can use the shape 2 package that has the cast, decast function and melt function. Melt function is to convert from wide format into long format, while the decast function is convert from wide format, so the long format into wide format. So you can read about this inside your material. It's in there. So that's basically it about this session. Then I think we are done with this module. And in the next module, let's see this. In the next module, we have session here starting from using functions and packages in R. That's using functions and packages in R. Sorry. So let's see if we can just say one or two things on this before we call it a day today. So in this session, we'll be talking about develop scripts and functions with R, use arguments with functions, explain the function environment in R, explain methods with functions in R, install, load, and unload packages for R. Now, so I can do some things for you, talking about data manipulation, calculation, analysis, and visualization. So it's one of some of its key capabilities include effective data handling and manipulation components, advanced visualization capabilities, operators for calculations, and the likes of this. I think um, so. Here we're talking about moving from scripts to functions. So instead of talking about scripts, scripts are just what you write in this your source source window. So maybe I've written some line of codes. I can just save it as .r file. So if I save this script now, it's going to be saved as .r file. That's the script on its own. Then if I want to run the line of code in this script from top down, I can use the source button after I've opened the script in R, or I use the source function like this. Then I'll specify the file I want to run inside the source function. And note, so let's say the name of this file is my script dot my script. I'll specify like this. Then I'll run it. So it's going to run everything in this script from top down. That's scripting. Now, moving from script to function, now instead of us having to do scripts, we want to do function, because script is not dynamic, because it's just based on a particular thing you have done. Then it already follows a particular pattern. It works with just a single data set. But function, let's say I created a function called sum. I can use sum on a particular data, the sum function up in a particular data, then another data again, I can use the sum function on it. Then I can use it on to do several things. But a script is just developed to solve to attempt a particular purpose. So instead of us talking about using scripts, you can create function to solve several things, or to deal with several scenarios. So using script. Now we've talked about creating scripts. We can create scripts in our source window here. That's our code editor, or use editors like Notepad, Microsoft Word, WordPad, and you now save it as a .r file. Then you can now run it on your R. Okay. Then so here we are trying to create a script. So inside my code editor, I typed x is this set of numbers. Then I'm saying, okay, percent is now round into bracket x times 100. So multiply this x times 100, round it up to one decimal place. Then the result is paste this percent together with the percentage sign, separate with it, nothing, with no space. Then print this result. So this is just a script. I can save it as any name I want to give it. Then after I've done that, next page please. So after I've done that, then I said to convert the given script into a function, you need to do the following: define the function, the name, and all of that. We are going to talk about function. So after I've done that, if I want to run this script, where is it not? Okay, as you can see here, after I've saved this script here, I can now source the script by doing this. So I save the script as paste percent. You can see it's a .r extension. Then I'll put source, then put the name of the script I want to run, then run it. So it's going to run from top down, and you can see the result here. The result is here. That is, it's going to show the final result. So, like if you write any print statement, it's going to print whatever you write in the script. If you don't put any print statement, you are not going to see the code in the console. It's only what you wrote in the script that if you write any print statement in the script, that's what is going to show in the console. It's not going to show the line of code. It's just going to run it, and if it's told to print anything, you are going to see it in the console. So because in here sorry, because in here I told you that print results. So it's this result that you are seeing here after I've solved the script. Now I can also transform my script to a function. So instead of saving as a script, I can create a function for it instead. So how do we create a function? Now here I'm trying to write a function now instead of creating my creating a script. I'm trying to create a function that's going to do the same thing that that script is doing. Now that script, if you look here, I created the X as this. So whatever I'm running the script is going to be using this X. So it's not dynamic. It means that I cannot use uh, this script to work on another vector because I've already created the vector it's going to work in. But as a function now, I can say, okay, create a function called add percent as what? A function that takes one parameter X. Now this parameter is unknown. It can be anything. So if the person I want to use it that's not going to pass that particular X into the function. So create a function add percent to be equals to function into bracket X. So it only has one parameter, which is X. Then what do I want the function to do? So inside it, I'm defining what I want the function to do. So I want the function to create a percentage object as what? Round X times 100, that is multiply this X by 100 and write it up to one digit. The result is paste percent as this result here with the percentage sign and separate it with nothing, with no space. Then return results. This is like a print statement. Return this. Then this is the end of my what of my function. Then if I should run this line, it's going to create a function called add percent. So if I want to perform anything with this add percent, I have to pass an argument x to it. So like a vector in this case. So if I pass a vector to it, it's going to multiply 100 to that vector, add the answer to one decimal place. Then it's going to paste the answer, connect percentage sign to it, separated by nothing, by no space, then return the result. So that's basically what it's going to do for me. So let's go to ask you now. Do you understand what I just talked about? Or after I've been demonstrated it? Hello, are we there?
Yes, yeah, yeah.
Okay, so now I'm trying to replicate the function that was created in that slide. So I want to say add percent. Now, so this is the function I want to create. It's called add percent. That's the name of the function I want to create. And I'm saying this function is equal to what? Function. We use the function keyword to create the function. Now, inside the brackets are the parameters the function is going to make use of. Now, parameters are optional. If your function is not going to take in any parameter, you can leave it blank. But a dynamic function obviously is going to take a parameter. So obviously. So if I want to just create a function without, so let me first of all create a simple function. Say I'll create a function called say hello. Say hello. So this function I'll create using the function keyword. Then after this, I'm going to put a curly brace that is which is going to define what the function is going to do. I'll go to the next line and say print. I want it to print hello world. I want it to print this. Now this function does not have any parameter. You can see inside the function is empty, there's no parameter. So let me create this. I'll run now. This function has been created. So if I call say hello now, say hello. Let me call this function. You can see it's printed what hello world. I didn't put anything inside it, so it printed hello world. because it does not take in any parameter. What if I put something inside? So let me put 23 inside. You can see error in say 23 or used argument 23 because it's not expecting any argument to be inside. So there's no point. So this is how it's built. There's no parameter. Hello. Now, but this function we are trying to create here is going to, so let me remove this function. Okay. Sorry. So this function add percent we are trying to create is taking a parameter called x. Our intuition in x is going to be a vector. So what do I want the function to do? I'll put a square, a curly brace where I'm going to write what I want the function to do. So enter. So in this next line, what do I want the function to do? So I want percent. I want to call percent. Percent. Percent is round x times 100. Round this um, operation to one decimal place. I can write digit is equal to one, doesn't matter, but the function already understood that I'm saying it's round to what one decimal place. Now, what next do I want to do? So this one, I take result is paste percent. That is this behavior I've created. It's going to do this first. So this one has x times 100 rounded up to what one decimal place. So in this next line, I'm saying that paste result together with the percentage sign, then separate it with nothing, that is no space at all. Now, the next thing I'm going to write is that I'm inside the function return, just like a police station, return result. I want you to return this result to print out this result. So I will run this command down. So I've created a function called add percent. Now I can now say if I want to use this add percent, I can use add percent, then to what? So I'm going to create a vector of fractions from 0 to 0.9. I'm going to increment by 0.1. So let me run this one. You can see that it did what I wanted to do. You multiply this vector by 100, add what the percentage sign to it without a separator. So from here I have 0. So what this vector contains 0, 0.1, 0.2 up to 0.9. So each of them 100 is multiplied to it, rounded up to one decimal place. Then the percentage sign is appended to it. That's the essence of this line. Paste percent with the percentage sign without the separator. So you can see I have 0%, 10%, 20%, 30%. So I can use that percent sign with any kind of vector I like. It's going to do what I told it to do inside this function. Exactly what I wanted to do. So that's how we can create function in R. So we are going to see a lot of functions as we proceed. I'm just going to try to help us get to creating functions in R. Okay. Do we have any question before we proceed? I think we just have less than 10 minutes.
So in the exam, we'll be required to do some scripting.
No. So you might be given a line of code and you are going to be asked that what does it do, what is it going to return, or what's the error in this code, something like that. Is multiple choice. The exam is multiple choice. So you are not getting any point. Like it's objective. Do you understand?
Okay. But will you suggest we should do anyway? It's not necessary.
Okay. All right, no problem. So what are you trying to suggest? So let me know. We should do what?
I'm just asking that the you guys said the video will be available. I was wondering, you suggest we should go and look for additional material or video to watch
It,
on
it,
the.
yes, you can watch additional videos online that talked about because you can't touch everything in class. So all those additional things you watch is going to improve your coding and your knowledge about things, some other things also. It's going to improve. So I'm going to be also sending some links and that you can access for all this learning that's going to help you in your exams.
Oh, thank you.
All right. So, moving forward, here is just like I'm using the ls function to see the object I've created. So just here that I created this function add percent. After I created this, I can see the add percent function in my workspace. So also formatting numbers. Uh, okay. So, so this one is very important. Okay. Uh, okay. You can also use functions. Uh, okay. So I can assign a function to another object if I like. So like the add percent function I created here, I can say okay, p percent, p percent is equals to add percent. The name of the function I created was add percent. So by the time I assign p percent to this add percent, like this, uh, text is missing. Sorry, like this. It means that this p percent can do exactly the same thing that this guy is done doing, was doing before. I'll just use p percent. I pass in my value of x. Let me just use the same value here. Pass it here. Then I run it. You can see it's doing exactly the same thing. So that one is just saying that okay, they just assigned p percent to p paste to add percent. So p paste is not doing exactly the same thing that add percent is doing. Now, talking about reducing the number of lines, that's dropping the braces or some line of code that you would sometimes some lines are not necessary. So for example, look at this now. Before I said the result is equals to this paste and I said return paste. I could avoid those two lines. I could avoid those two lines by just saying uh, I'll just remove this. I remove this and remove this. So this paste percent blah 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 is exactly this. So me, I'm just trying to assign it to this, then I'll now say return this guy. So I can just remove this line and this line. It still does the same thing. Also, I can drop the brace sometimes. So for example, uh, testing for this guy now that I created here. I said you should print early. I can remove these braces like this. Then I'll just drag this one like this. To say hello is what function. Then after that, I want you to do this. So let me run this guy. That's created the function for me. So let me say hello now. Say hello. I see hello world. So, but it's just makes it easier for you to be able to understand your code. This basis is going to guide you in writing your functions. It's very essential. Don't love the basis. The basis helps you to understand your code very well. So, but you can drop the limits. So, returning values by default. Now, talking about returning values by default. Okay, sorry. So, this one is just like this guy. Okay. So, I'm saying I can just return this guy instead of using the return function. I can just do this. It's still going to give me the same thing. I can write this without using the return statement. I can just omit that line. Also, here I'm trying to make my code more dynamic using a conditional statement. So what I'm trying to say is that I'm creating the function add percent with parameter x. Now, me that I'm creating the function, I know that the function takes input vector and it has to be numeric variables. It has to be numeric variables because I cannot do x times 100 on I cannot do multiplication on character variables. So I want my function to check if it's not numeric. This exclamation mark means negation. Now is not numeric, x means check if it is numeric. This exclamation mark is saying is not numeric. So if it is not numeric, return null as the result. Else, then proceed to this one and now do my operation for me. We are still going to talk about this conditional statements later on. Then I think the last one here I'll just say this dropping the brace. I've talked about dropping the brace where you can see that here I'm creating a function called alt which takes in a parameter called x. Then I just put a space and I just wrote what I want the function to do. I want the function to do x divided by 1 minus x. I can do that. So we are going to stop here for now, and by next week we are going to continue from where we stop. Do you have any questions so far?